All right. So on subpart 2, this first one, you don't need a calculator. So a supermarket owner wants to know whether in the supermarket he should locate the bread or where he should locate the bread to maximize sales. So he puts it in one location, counts the loaves sold, and puts another location and counts again. So what do you guys think? Which is this? Experiment, observational study, experiment. Good. So observational study, I guess, would be if the bread was already located in two places and he just observed and compared. A sample survey would be if he just asked customers about where they want the bread located, I guess. And then two-stage sampling we've never talked about, so it's probably not going to be an answer. Okay, number 2, we go over to the side, which is different than we normally do on these sheets. And this is actually a calculator question, but it's set up in a way that it's hard to recognize. So a new statue in a local park has length L, width W, and height H, all in feet, and expressed by this system of equations. So what we're going to do is write 3 equations that have L, W, and H. And so that first equation has 1L plus 1W, and there's no H's, so we're going to put in 0H is equal to 28. All right, and then the second equation is 1L, and then this one has 0W, and 1H would equal 26. And then the last one has 0L. All right, and what we need is RREF. Any ideas? I want to give you a hint. You start off with second. Look at your calculator and see if you can figure out what you hit after you hit second to get RREF. Sometimes it comes back to you when you look at it. Anybody? All right, you hit second and then x to the negative 1 because we want the matrix menu. And then after that, you're going to go over 1 to the right, and then you choose B, which is RREF. All right, so jot that down, and then I'll do it on the calculator. And you can do it on your calculator too, because it helps to actually practice it if you want to remember it. Hey, Jonathan, you need to put your phone away and take your earbud out. Okay, so once you choose it, that is what it looks like. Okay, and then we need a matrix that we're going to put in 1, 1, 0, 28, 1, 0, 1, 26. And so do you guys remember how to get the matrix? It's okay. It's alpha, zoom. I forgot for a second. And then you need to choose 3 rows and 4 columns. Now, all of your calculators are going to be reset before you take the EOC. So I think when it resets to 2 and 2, but I'm not sure. So you'll probably have to change that on your calculator. All right. All right, and then you're just going to go through and put in these numbers that we just wrote. And this is what we get. So as long as these are like all zeros and then one's diagonal, then these are the answers. And so whatever was first, which was L, is going to be the 16. And then W was second, it's going to be the 12. And then H was third, that's going to be the 10. And the question was the width. So the width is the second one, so the width is 12.
I'm not even gonna lie, I guess I still got that right.
Oh, good. Okay, that was a good guess because that one it would be hard to do, hard to remember. Okay, and then number 3, we are going to use a formula that is on the reference sheet. So on number 3, a post is being driven into the ground. The first strike drives the post 25 inches into the ground, and each additional strike drives the post 4/5 of the distance further. All right, so this is going to be hold on. We want the total distance that the post has been driven. So that's going to be a sum. So this is going to be a geometric series. All right, and there's a formula for a geometric series. So on these formulas, S is always going to stand for the sum. And you don't have to memorize that formula. It's going to be on your reference sheet. You're just going to need to be able to find it. Hey, Isaac. Okay, and so N is basically the number of strikes. And so this is going to be S sub 7. Do you guys remember what A sub 1 is on all of these formulas? A sub 1? The first term. And so the first term is how much it drove. Yeah. How much it drove it in the first hit, which is going to be 25. And then R is going to be that 4/5. Okay. So I am just going to type that in the calculator like it looks. You guys can too, just to make sure. Right, now, none of the answers are exactly what your calculator gives you, but obviously you're going to pick the one closest, and so that's going to be 99 inches. Okay. Number 4 is also an equation that is on the reference sheet. Sorry. So a circle is cut in half, and then one of the halves is halved, and then halved again. They just keep finding half of the circle. So this repeats a number of times. The area of the original circle is 144 pi. That's going to be a sub 1. We want a function that represents the area of the smallest piece of the circle after x cuts. So this is going to be a geometric sequence. So I'm just going to jot the formula down. It's another one you don't have to remember. Now this one doesn't look exactly like the formula, but in this case the a sub 1 is the 144 pi. And R, if each one is half as big as the original, R is actually going to be 1/2, or in this case, is 0.5. So none of them look exactly like the formula, but which one looks the most like the formula? Which choice? It's definitely C. So these two have subtraction in between the first term and the thing, and so that's not going to work. And then this one is multiplied by x instead of raised to the power. So C is going to be the answer. Okay. Now, number 5, I'm going to show you 2 ways. One way is to actually solve the problem. Another way is to just check it in the calculator. So I actually have this exact same problem on my pre-calculus review, but we can do it also. On this one, we're going to solve by the quadratic formula. Does anybody remember it? It's a song. Everybody likes to sing it. B squared minus 4AC divided by 2A. Good. Do you need a pencil? Okay. All right, so A is 2, B is 2, C is 5. So I'm just going to put 2 in for B, 2 in for A. Oops, forgot the 4. And 5 in for C. Now, we didn't put this whole problem in the calculator at one time. What we would just do is we would take what's underneath the square root and just put that in. So 2 squared minus 4 times 2 times 5. That's going to be negative 36 underneath the square root. So what is the square root of negative 36? Do you remember? Square root of a negative is always going to give you an I. So the square root of negative 36 is going to be 6I. Now that is not an answer choice, but we're getting close. So that on that answer choices, you guys might remember we would draw this heart. And everything inside the heart, if it can be reduced by the same number, you would want to reduce it. And we can reduce all of those by 2. So that's why those are the answers. So that matches up with choice D. Now that's a lot to remember. So I'm going to show you that you can actually put I in the calculator and just check the answer choices. Yes, ma'am. Yes. You're welcome. Okay, so the answer is D. But if you don't want to go through all that stuff, there is an I button on the calculator, and it is seconds and then the decimal point. So if you look at the decimal point above it, there's a blue I. So anytime we want to do I, we do second and the decimal point. So if you wanted to check 1 and 2, that's easy. You would just do 1 store x and then type in 2x squared plus 2 minus or plus 5. All right, and I don't get 0, so A is not an answer choice. All right, and then you check as many as you want to, but when you go to check C, we go to check D, which I know is going to work. To type that in, you're going to do -1 plus 3I in parentheses. and then divide it by 2, and store that as x. All right, and then go back up, choose it, and you do get 0. So if one of those works, they're both going to work on the imaginary solution. Now, your calculator won't let you do like the alpha y equals fraction bar with eyes. It'll give you an error every time. I don't know why. It's just kind of like a glitch in the calculator. So I'm going to write all these things down if you want to jot it down and use the calculator to solve those. So what you would do is -1 plus 3i divided by 2, and then store x. And then anytime you want to get I, it's second, and then the decimal point is going to give you I. Now, when we learned about that, I didn't show you how to do I in the calculator because most of the stuff that uses I is on the non-calculator part of the test. But if for some reason, if I put something on there with an I on the calculator part, feel free to use that button. It's very, very helpful. All right, so number 6 is another formula that is on the reference sheet. So Joyce deposited $5,000 into an account with an annual interest of 6% compounded annually. How much money will the account have after 10 years? So when you see compounded annually, that's the compound interest formula. So I'm just going to jot it down. There's no reason to try and memorize it. It's going to be there on your reference sheet. But we have to figure out what A is what we're looking for. We need to figure out what PR and N and T are. So P is always the amount you deposit. So P is going to be that $5,000. R is the interest rate as a decimal. So 6% as a decimal is going to be 0.06. All right, N is the toughest one to figure out on this one. If something happens annually, how many times per year is that? 1 time per year, good. And then T is going to be 10 years. Okay, so I'm going to go back and just plug all these things in. Oops, forgot the 1. All right. So that's going to be your answer, choice D.
Exponential growth, and I still don't know where I hit.
Oh, it's basically the same formula, really, because annually. So that will only work if it's just if N is 1.
You said the damn with you.
It is.
Olivia, I guess I guessed good.
Okay, we're going to try to get through 9, and then we'll pick back up on Monday with the rest of them. That'll be a little bit more than half. Okay, number 7 is super easy, and I honestly haven't looked yet to see who missed what question or whatever. But if you're looking to see where something is increasing, is it obvious to you where this is increasing? Yeah, so it's increasing where we have this positive slope where it's rising. So that's definitely between 5 and 12. So that'd be choice B. So increasing goes up from left to right, decreasing goes down, and then flat is going to be constant. Now, a lot of people are like, you didn't teach us this. Well, I didn't teach you 8, so I will give you that. It's not, to me, I don't see it in our standards, but it's on the practice test, so maybe it is, and I just missed it. But there is an arc length, like if you think of a pizza and we took a slice, the arc length is like the length of the crust of the pizza. That's going to be the arc length, and that's represented as S. I didn't even hear it. I think I'm getting old. I didn't hear it at all. I'm sorry.
And I was like, that teacher, she said, I don't know why they're doing this.
Oh,
She said, I've seen like all the kids and the home is locked out.
yeah, it's for safety. All right, and then R stands for the radius, so you guys know what the radius of a circle is. And then theta is this angle right here. Now, I feel like you did this in geometry, although my last class didn't think that you did, but I've been wrong before, so it's fine. So the formula for arc length is S equals R theta. I did teach you about theta, changing it to radians and degrees, and then I did that, but that is just not this problem. Did you get it right? Oh, do you know this formula? You just guessed? Okay, let's see. So we're going to put 10 in for S, and we're going to put 5 in for R, because arc length is S, R obviously is 5. And then what would you do to solve this for theta? What would you do with that 5? Nobody knows? If you had 5x equals 10, what would you do? Divide by 5. So we're going to do the same thing. We're going to divide by 5. So theta is 2. All right. I don't think I taught you arc length formula. Maybe. Okay. Yeah. Yeah, you're right. If you understand what an arc length is and what the radius is, then you probably can logic. Yeah, that probably helps too. Okay, let's do 9 and then we'll pick back up on Monday. So every year, Beth doubles the amount she donates to charity. She donated $1 to charity at age 10. How much is she going to donate at age 20? Some people just figured this out by multiplying. Is that what you guys did? What'd you get? Yeah. So that's what everyone pretty much in my last class was like. I just did 1 times 2 times 2 times 2 times until I got to 10, until I got to 20 years. There is a doubling formula. The doubling formula is like you take the initial amount, we'll call it P, and it's 2 raised to the T. So in this case, it's $1 times 2 raised to the 10 because it's been 10 years. But I really feel like you have a better chance of remembering, just figure it out by multiplying by 2. All right.